we can start the design part. Today our goal is to switch from window width to full screen mode, but before to do that we need to do some important preliminary tasks. The first step to do is to make our window resizable. This is non-mandatory, but it's important to understand how to switch correctly between window width and full screen modes. To make our window resizable, in the window constructor class, we need to pass a flag called WSOverlappedWindow in the createWindowX method. Then we have to define and implement a new event or callback method called onSize. This method will be called in the window procedure when the WNSize event is fired, in the same way done for the other events, like onFocus. WNSize is an event fired each time the window is resized. Then we will simply inherit the onSize method in the appWindow class. Once we have done this step, we are finally able to resize our window, but unfortunately, the 3D scene will not be rendered correctly. It will appear stretched in all directions. This happens because the size of our swap chain is not updated with the new size of the window automatically. For these reasons, the second step to do is to resize our swap chain. To do this, we will add a method in the swap chain class that we will call resize, with two unsigned integer parameters, width and height. The resize of the swap chain is not so straightforward. As we have already seen in the previous tutorials, the swap chain is composed of a series of render buffers. One is the render target, saved internally in the D3D11 swap chain, where the final 3D scene is rendered. And then there is the depth buffer, that allows to render correctly the various parts of the rendered 3D models, in such a way to render front parts over the back parts. So, the resize of our swap chain consists mainly to resize these two buffers. The resize of the render target is already handled by the D3D11 swap chain. We have only to call the resize buffers method. The resize of the depth buffer, instead, must be done manually. This because we are handling the depth buffer on our own. Luckily, we have already implemented this functionality, that is the swap chain constructor part in which we create the depth buffer. The process is the same. In conclusion, the final resize is done in this way. As first thing, we have to release all the so-called view resources, so the render target view and the depth stencil view. Then we can resize the render target with the resize buffers method and the depth buffer. At the end, from this buffer, we can recreate the view resources that are used by the device context to bind the render target and depth buffer into the graphics pipeline. Once this step is done, we can easily call the resize method in the onSize method of the appWindow class. Well, but at this point another problem arises. The scene is rendered, but only after the resizing process. To solve this issue, in the onSize method we can easily call onUpdate method after the swap chain resize. Very well. Once we are able to correctly resize the window and the swap chain, the first step, that is the switch from window width to full screen mode, is quite straightforward. As first thing, we have to add a new method in swap chain class called setFullScreen, whose parameters will be a boolean parameter called fullScreen and two unsigned integer parameters called width and height. FullScreen tests to the function in which mode we want to switch, window width or full screen. Width and height instead indicate the screen resolution. After this, we have to set an important flag into the swap chain constructor called swapChainFlagAllowModeSwitch that, as the name suggests, allows the swap chain to switch into window width or full screen modes. Then, in the setFullScreen method, we will simply call another T3D11 swap chain method called setFullScreenState that will actually allow us to switch to window with or full screen mode. Before to call this method, let's remember to call the resize method. In this way, we will have the render buffers already resized to the resolution indicated before the switch takes place. Very good. Now we have all the necessary information to start the implementation. As first thing, let's go to Window class and let's add a new virtual method. Let's call it onSize. Then in the Windows C++ file, let's go to the window procedure and let's handle a new event called WNSize. As we have already said in the introduction, WNSize is fired each time the window is resized. Now let's copy past the code of the WMKillFocus event and let's substitute the onKillFocus with the new onSize method. At this point we can go to App Window class and we can start to implement the onSize method. In this method, as we have already seen in the introduction, we have to resize the swap chain. To do that, as first thing, let's get the window size. Then we can go to swap chain class and add a new method called resize. Let's add two parameters called width and height. Now we can start to implement the resize method. As a first thing, let's resize the render target by calling the resize buffers method. Let's take the same surface format used in the constructor Here we have to recreate the depth buffer with the new size. Since this process has been already done in the constructor, we can easily use this procedure both in the constructor and in the resize methods. To do that, let's implement a new method called reload buffers. Let's put the same parameters used in the resize method. Let's go to the constructor and let's move all the code that starts from the creation of the render target view to the reload buffers method. Let's fix it a bit in order to resolve the errors. Then we have simply to call reload buffers in the resize method. As we have seen in the introduction, let's remember to release the render target view and then stencil view before the recreation of the various buffers. Let's call reload buffers even in the constructor. Very well. Now let's come back to app window class and in the onSize method, let's call resize from swap chain. At this point, let's go to window class and let's make a check before the call to onSize method, because WNSize can be called before the window pointer is settled. Then let's go to the constructor method and let's make our window resizable by using the WS overlapped window flag in the create window X function. Very well, let's go to app window class. Here, since we want to test the resize feature, let's disable temporarily the camera mouse movement. Let's see if it works. And it works, but the scene is not rendered during the resizing process. To solve this issue, let's call in the onSize method the onUpdate method. In this way, each time the resize of the window takes place, the scene is rendered accordingly. Let's see what happens. And it works! The resize feature now works completely. Good, but now we are not able to move our camera anymore. Since we want to both resize and move or rotate our camera, let's introduce a playState boolean attribute. This attribute allows us to switch from a state in which we can move our camera and another state in which we can move and resize our window. This will be useful in the future when we will introduce a menu for the game. The state can be toggled each time we press the G key. At this point, let's go to onMouseMove method and let's enable mouse movement only when we are in the play state. Then let's show or hide the cursor in base of the play state. Let's see if it works. And it works! By pressing G, we can switch from play to not play state. At this point, let's do the same thing for the full screen state. Let's toggle this state when we press the F key. Very well, now we have to go to swapChain class and implement the setFullScreen method. Here, let's call from the swapChain the setFullScreenState method by passing the fullScreen parameter. That indicates in which mode we want to switch, window width or full screen. After this, let's remember to set the flag in the swapChain descriptor that allow the mouse switch. At the end, let's call in the setFullScreen method the resize method. by passing the width and height parameters. So far so good. Let's come back to app window class and in the onKeyApp method, let's call the setFullScreen method just implemented. Now we have a problem. What are the width and height of the screen? To retrieve them, let's go to window class and let's add a new method called getScreenSize that returns a rect object. Here we can retrieve the size of the screen by calling the Windows API function called getSystemMetrics. By using the flag smcxScreen, we will get the width. By using the smcy screen instead, we will get the height. Very well, let's come back again to App Window class and finally here we can retrieve the size of the screen and pass it to our method. Now, since when the switch takes place, the onSize method is called automatically, and since the switch happens only when the input system is updated, we cannot call onUpdate in the onSize method. This because the input system is updated exactly during the onUpdate method, and so in this way we will cause a stack overflow. To avoid this issue, let's move only the rendering part from the onUpdate method to another method that we can call render. At this point, let's call render both in onUpdate and onSize methods. Very well. As very last thing, let's enable play state as default at the initialization of the application. And that's all for now, folks. Today we have seen how to resize a window and how to switch from window into full screen mode. I hope you enjoyed this video. See you soon. Thanks for watching.